Hello and welcome to PCI's DEM Editing Best Practices video guide series. In this chapter 1, we're going to look at getting started with large high-resolution DEMs. Our main objectives in this video include 1. Reviewing the output from PCI's DEM extraction process, 2. Initializing our DEM editing environment and loading our data, 3. Understanding the basic tools, and 4. Learning how to approach a large DEM editing project. To get started, we're just going to open up our Geomatica toolbar as well as our focus application. So then the next thing we want to do is navigate to where the DSM has extracted to after running the OrthoEngine or GXL process. So now I can just drag and drop it into our focus viewer, and we can see that our digital surface model is now rendered. Now let's just quickly take a moment to understand what is in this file. So yes, of course, we have the 32-bit high-resolution digital surface model, but if we also take a look, we can see that we have 3 additional image channels. So this is a coarser resolution of the orthomosaic that would be generated using this DSM exactly as it is. So to start or initialize our DEM editing environment, we can simply select the digital surface model that we loaded into focus, go to Layer, go down to DEM Editing, and 2 things you'll notice have happened. 1, our DEM editing window, which contains our tools and viewing capabilities for our DEM directly on it, as well as our DSM has now been rendered in a pseudo color hillshade image, which is quite dynamic. So as you can see, the colors change as we zoom in and out. So if we take a look, this is a digital surface model that was extracted directly from Pleiades imagery. So we can see we have pretty good detail. We have an urban center here, which is Melbourne, and then we have topographic relief in the outer regions. We also have a water body. One of the first tools that you're going to want to get used to using with our live DEM editing environment is just the ability to quickly switch back and forth between the preview mosaic as well as the DEM. So this main benefit of this is that it allows you to see what feature that the particular elevation values were extracted from. So we look at an area like this, we can see it's quite messy. So the first question that I might ask myself is, what is this area of? Once we see that it's water, it becomes a little bit more understandable that we would have issues extracting the elevation values in water. Okay. So another thing that's important is learning how to get started with the actual editing of our DEM. So the way our DEM editing tools are set up is it is 2D mono editing. So the first thing we want to do is we want to just create an editing layer, as we can edit this DEM in sections or segments. So right here I can just simply click on Create Polygon Layer, and that's going to create our DEM editing polygon layer. So if I want to edit an area, for example, if I just want to filter out the buildings in downtown Melbourne, I can click on this new polygon tool, draw a polygon around the outer reaches of the downtown core, have my polygon, and it can be a completely irregular polygon, so it doesn't really matter how many vertices it has. And then I can choose from our operations drop-down list an appropriate method for filtering out these features. So we have one of our methods, which is the terrain filter, which I can use for example. I'm just going to show you this just as an example for now. So I can set a size if I want to increase the size of the building that I want to remove. I can do that. It's relatively flat area, so I can lower the gradient, and I can simply just click apply. So after a few seconds, our filter should go through, and we've generally removed most of the features. We can run it multiple times. The nice thing is that it detects buildings versus terrain, so the more you run it, it will not necessarily degrade your terrain features. So we can see that just from that we've removed the surface features of a large chunk. Okay, so those are some of the main tools that you're going to have to get used to using. It's also important to be able to learn about our undo tools, because sometimes you'll make mistakes or you'll want to do some trial and error in an area, and you'll have to undo and redo just to see how the results look. So another tool that's important to introduce you to is the Open Fly tool. So we can zoom out to an area, and I can click on our Fly Through option, and what it's going to do is it's going to render a 3D fly-through environment for our region. Okay, so we can see we have the buildings, and then we can just fly through, and it gives us a different perspective so we can begin to see how our DEM looks, just from a 3D perspective here. So we can see bridges, we can see overpasses, see the basics of buildings, and so it can be quite useful to have this fly through, especially if you're editing forest areas. So the last tool that I want to introduce you to before we take a look at how to approach this entire DSM in general is our verification tool. So we have a tool here known as our preview window, where we can take a look at the orthos that are generated from this DSM. So we can click on here, and we're just going to draw out a window that covers a region of our digital surface model. Now the concept that we're employing here is that when we generate the orthos using the active DEM in here, if our elevation values are accurate, then the features in the DEM, the ground features, at least the terrain features, should be almost perfectly aligned with one another. It doesn't matter which viewing angle or looking angle we're using, the ground features should be in the same place, hence the point of orthorectification. So if we just look at our DSM, we look at an area and we filter back and forth, you can see that we have a very nice, very stable product here between the two ortho images. So then that tells us that our DSM is accurate, but obviously we're going to get artifacts in our buildings that we need to filter out the surface features to remove this. So we'll close this window for now. We'll reapply our edits here. So I'll select this area. I'm going to apply the terrain filter twice to this region. Then we can redraw our one-to-one window over an area, regenerate the orthos in this region, and we can do a similar test. So now what we should be looking for is that the terrain features such as the roads and the park area here, the grass, should be very stable, but surface features like trees and buildings will move back and forth, but they should at least be regular, not necessarily deformed. As you can see, the trees move back and forth, the building moves back and forth, but the streets and everything's very stable. So this can help us detect errors. Now just to further emphasize this point, let's just make a mistake here to show you what kind of results you would get if you have an inaccurate elevation values. So we can go here, for example, average elevation. This is just going to create a flat surface. As you can see, it's not perfectly flat. So we'll just go apply. So we create a flat surface here. We take a look at our orthos. We regenerate them based on our current values in our DEM. And then when we filter back and forth, you can see some major shifts occurring on the terrain features such as the roads. So this is what we would be looking for to see if we have an accuracy issue in terms of our elevation values. The nice thing about this tool as well is that while it does allow you to evaluate the vertical accuracy of your DSM or DEM, but it also gives you the ability to just view and see what your orthos will look like before you generate them. So now that we've been introduced to the basics of using the DEM editing tool and its verification tools, let's take a look at how we would approach such DEM. The first thing that we need to understand are the operations that are available to us. So to expose these, I'm just going to draw a polygon on our DEM. So once I've drawn our polygon, we get access to the different operations that are available. Basically, we have two categories. We have general filters, so everything from average filter down to remove pits would be something that you would apply on a large region like this. And then we have more specific tools, so everything from fill edges down to add elevations are things that you would apply on smaller regions to fix very specific features such as these bridges here or the intricacies of densely packed urban area. So when we're looking at a DEM with all these different features in it, the first thing we want to do is we want to draw polygons around the features that we're going to want to spend a little bit more time on with some of these specialized tools. So the first thing I can look at is this dense urban area here. I may want to use some different settings or some different tools to kind of work on this area. I also have a long overpass over here that perhaps I would want to spend a little bit more time on that. Same thing over here, we have this bridge feature that's quite important as it's the prominent feature in this area that we may want to spend a little bit more time on. And then we can also just choose, for example, we have this river system with this valley region here that may require a little bit more specialized work on. So once we've identified the major regions that we want to just sort of isolate and remove from the general filtering, we can then go through and probably do about 90% of this DEM with these generic filters. So I can start off by simply selecting this feature here, and then I can apply these different features. So we're just going to work on this one area, and I usually start off with the clamp filter. So the clamp filter just helps clamp everything down, and it usually doesn't do much visually, but it provides a better result when we run the terrain filter, which is the major operation. So I can just click apply, which will apply everything to this, apply the changes to everything inside of this polygon, but not including the features inside of this polygon. Then after that I can go to terrain filter. I'm going to change my size, say something a little bit more larger, so maybe 200 pixels, keep my gradient the way it is. I still have my selected polygon, and then I can go apply as well. Okay, and now you can see that it's done majority of the work that I need for this area, but we still have some bumps and we still have some pits that we may want to filter out. So the other generic filters we can use, for example, remove bumps. Maybe we can make it a little bit bigger, and we can just go apply with, a regular apply. You can see that we removed a fair number of those bumps, still without touching the area in here. So if we click apply with overwrite, then it will apply to everything inside this polygon as well as other polygons within it. So we only want to use that in certain situations. So the last one I'm going to do for this area, just to clean it up, so I'm going to go remove pits, and then I can go apply again. It's going to fill in some of these pits. Okay. So after I've done that, I can use my accuracy tool to just get a quick overview or quick look at the accuracy in some of the different regions, so sample different regions. I can go back and forth, and I can zoom into an area, and I can see that my street is quite stable, which shows that I have good vertical accuracy in this region. Okay, so then once you've done the majority of your DEM with this same approach, with all going over the different areas, then you can begin focusing on the more specialized areas that you've excluded at this point using some of these specialized operations. The subsequent chapters in this series are going to teach you how to use our more specialized tools and how to approach more complex features such as the urban centers, the bridges, overpasses, and so on.